Today's video we're going to be unboxing, assembling, and going through the first couple of prints as well as some diagnostic prints on the Eryone ER20, and here we go. Folks, welcome back. I am so sorry we haven't talked in so long. My October was hectic. I run an Etsy store kind of parallel to this YouTube channel, and it just went on fire last month, which is I'm so grateful for. If you're a customer and you're also watching the video, thank you very much. But it left me in a pretty tough position, and by tough, not by my standards. I actually had to buy a few more printers for the fleet here, and in doing so, I kind of stumbled upon this printer. This is the Eryone ER20. It jumped out at me while it was on sale. It's kind of a perpetual sale as far as I can tell. This printer costs $159. That's including tax. That's including shipping. This printer is feature rich. I don't know how it could be costed that low. I hadn't heard much buzz, much word about this printer, so I kind of thought it was a write-off. I figured there's going to be some cheap components. Maybe it wasn't that good. Well, I unboxed it, I assembled it, and I even have it printing right now as we speak. Some of the features. Everything is in this base. That is our main board, that is our power supply. That's really cool. Our main board is silent, 32-bit, equipped with TMC 2209 drivers. Why does that matter? Because those drivers are also what home our printers. We're using sensorless homing, meaning there's no micro switch for the x-axis, no micro switch for the y-axis. Normally on printers like this, on our Voxlab Aquilas, our JL S8s, our Corel Under 3s, to home the x-axis and the y-axis, the x-axis will come across, contact the micro switch, it'll know it's at home. Same thing with the bed or the y-axis. It'll come all the way back, contact that micro switch, and it knows it's at home. This printer doesn't have any micro switches. It's going to utilize those drivers to tell when it's home. How does it do that? Well, constantly while the printer is working and the axes are moving, those drivers are maintaining two things: the load and the torque that's being applied to the stepper motors. So as the x-axis is homing itself, the load and the torque is generally consistent until it gets to this point. It hits a wall, it stops. The load shoots up, the torque shoots up. The stepper drivers read that, understand that, and know that the X is now homed. The same thing goes with our front to back, our Y axis. The bed moves all the way back. The torque, the load remains fairly constant during its travels until it hits the back of this printer. The load shoots up, the torque shoots up, and these TMC 2209 drivers can tell. And they know at that point the Y is all the way back and it's homed. That's pretty cool. How accurate is it? In my experience, it's been pretty accurate. In the beginning of my prints, I was getting some purge lines that actually were going off the front of the bed. I made some slicer settings, some firmware settings, adjustments rather, and since then I haven't really had any problem with that. Now, the Z-axis, the vertical up and down, doesn't use sensorless homing. It actually does use a sensor, and it's an important one. It's an auto bed level sensor. Now, you'd be familiar with this as a BL Touch. This is the ER Touch, the Eryone Touch, and it's what's going to control the Z-axis. So this printer comes equipped with an auto bed leveling device, already programmed in there, already set up. That's kind of a big game, kind of a big deal. I really like it. Now, what's driving that Z-axis up and down? Normally, it's a single Z-rod and a single Z motor. In this case, it's dual Z-rods, dual stepper motors for those. That's also really cool. Sometimes you'll get the two rods and a single timing belt across and a single motor. This opted against that. It went with the double rods and the double motors. Really, really cool. Even the frame here is interesting. It's got a measuring stick basically all the way from the base to the top. And that's going to help us later on when we're trying to level out this x-axis gantry. Instead of getting a measuring stick or something of unique height or similar height that we put on either side, we're just going to use these measuring marks. It makes it really, really simple for us. So that's an added benefit. Now, the build size is one of the hampers of this printer, if you could even call it that. A printer of this size, this nature, is generally 235, 235, 250. This comes equipped 220, 250, 200. So the actual bed size is a little bigger in, I believe, the Y direction, but it's smaller in your vertical axis. So you're not going to be able to get those big prints on it like you could a Corel Under 3, a Voxlab Aquila. Now, that hasn't stopped me so far, and as a matter of fact, The printer I'm printing right now is going to utilize the entirety of this Z-axis, so we can get a ganders on how well it can do that. But it's definitely something to take into account. Enough talking about this. I'm excited. I really want this printer to be good. I don't really know if it is, but I want it to be. Because this price, this is a beginner's printer. You unbox it, you assemble it, and you kind of just start printing. Speaking of that, let's go ahead and get to it. Unbox, assemble, and print. So unlike some of the printers we've seen on this channel before, this doesn't have a lot in the box because it comes mostly pre-assembled. Now the first thing we're going to see when we open this box is this pretty thick instruction manual. It's really cool. It's in 5 different languages. It's about 28 pages per language, and it goes over the installation of the printer parts, a quick installation guide, but also the different menus that you're going to find on this printer. Really cool. You don't see that a lot. It goes into every menu and then the sub menu, so you can kind of understand what's going on. You might look and you just see configuration. You really have no clue what that menu is. This booklet explains all that. It also goes over some maintenance. And like I said before, it also has a quick installation guide, which this is right here. If you don't want to look at that big booklet and you want to just jump right in, this quick installation guide runs you through how to get this up and running. Then we get some filament. I got some white filament, it's a test filament. I never use this. I get grief for it, but for whatever reason, I just tuck it away in a corner and I use it another time. After that, we have this parts toolkit. Kind of the normal fare, USB cable that we can connect it to our computer with, a spatula, a filament snipper, all the Allen wrenches we need, a spanner. But then we get a few extras. Extra PTFE tubing, extra nozzle, extra belt. Those are kind of the outliers that we don't normally see. Really nice to see that here. Then we have our power cable. Then we have our 2 Z-rods, both greased. And next we're going to see, this is our upright. This is the Z-axis rails as well as the X-axis gantry. Now attached to all this is also our hot end and our extruder. So this is already pre-assembled. Normally this is a 3 or 4 step process to get these things together, the belt, the axes, all this. For us, we're just going to put this on the base. Speaking of the base, that's the next thing in the box. It comes with the glass bed attached. Also had a lot of styrofoam underneath it, which was good because not only during shipping it didn't move, but when you took it out, the glass bed didn't shift or rock at all. As you'll see here on the LCD screen, the knob isn't there. That is one of the parts that came with our part toolkit, and that's one of the installation steps, putting that knob on. So before I installed this printer, I just wanted to take a look at its guts a little bit. So I turned it over, I took the baseboard off. Pretty simple to take it off. Besides the screws that you see exposed, you'll also have to take off the screws that are in the little feet, the rubber feet that are on it. Then it comes right off. You just want to be careful with the cooling fan. The cooling fan is attached to not only the baseboard that gets removed, but the motherboard. And it's got a small wire. So if you were to take this off way too fast or way too hard, you're going to rip it out. You're going to ruin it. How do I know this? Because that's exactly what I did. Luckily for me, I did have a spare fan, so I was able to get this thing back up and running. But if you do not, you're going to be slightly out of luck for a while because your motherboard will not be cooled if you break that fan off. So if we're looking at the internals, at the guts of this printer, everything looks pretty good. The wiring's all neat. It's all in place. We can see it does have the TMC 2209 drivers. We do have not 1, but 2 stepper motors for our Z-axis. That's our vertical axis. We have the Y motor back there as well. And then we have the power supply neatly put in its place. Now, the one weird oddity of this whole thing is the power supply voltage selector. Now, I am in the United States, so I want my voltage to be 115. However, on these power supplies, there's an option, 115 volts or 230 volts. Generally, you will go to the selector before you start up your printer. You'll change it to the correct voltage, and you'll be on your way. And it's usually exposed. The voltage selector, though, is right here. It's that little red speck that is buried within the base of this printer. Now, when I opened it up and checked it, mine was already at 115 volts. I would still take this baseboard off and check. I am a nervous Nelly, and I want to make sure that my voltage is correctly adjusted. Now, that's basically it for the unboxing. Normally, you'll see a lot of different axes and extrusions come out. But like I said, this is pre-assembled already. The installation is going to be very quick. So that's all we're getting out of the box. Now, before we do install everything, I want to jump into some of the components on this printer because they are a little different than we'd normally see. Now, right here, we're looking at the back of our hot end. Generally, the layout is similar. We have a thermistor on one side. We have the heating cartridge on the other. We have a small fan that's next to the hot end. What makes this a little different is this hot end is attached to the fan shroud. Now, on a lot of other printers, our Voxlab Aquila specifically, the hot end gets attached to the X-axis carriage. This does not. That worries me a little bit. When the hot end is attached to the X-axis carriage, we can tighten it down and we know it's stable. However, with this, we have to tighten the hot end to the fan shroud, and then we have to make sure the fan shroud is tight to the carriage, so then we get no play in that hot end. Now, I don't think it's going to cause much issue, but it's definitely something to take a closer look at. You want to make sure that not only your hot end is tight to the fan shroud, but then now your fan shroud needs to be snug to the X-axis carriage, so there's no vibration or movement during printing. Another thing of note with this hot end, the PTFE tubing goes all the way down to the nozzle. We're not the biggest fan of that, but that's common with a lot of these hot ends, with a lot of these printers. There are some times with a hot end like this, you might see a heat sink between the nozzle and the top of the PTFE tubing. That is not the case here. Now, the mounting of the thermistor on this hot end is also a little unique. Oftentimes, the thermistor is either screwed into the heating block or it's placed around a screw that is then screwed into the heating block, and that screw holds it in place but doesn't tighten it down because we don't want to crimp it. The way Eryone decided to manufacture this, the thermistor goes in, gets inserted into the heating block about 20 millimeters. It's in there pretty deep. And then the silicone sock goes around the heating block, and that holds the thermistor in place. All right, and it's onto the assembly. As you'll find out, it's really not all that tough. Eryone has done a pretty good job of making this very quick and painless. First thing we're going to do is get the uprights going. This is the Z-axis frame, along with the hot end and the extruder. Now, you'll see right here, it just snapped in place. There is divots or holes where this axis actually sits. So right now, as it is, I have no screws in there, and the axis is sitting on top. It's really, really cool. It makes putting this together a lot easier. We are going to screw it in, though, of course, and these are the two large screws we're going to use. Fit them with a washer apiece, and then what I do is I move the printer off a table just like this so I can get under there and access the bottom easier, and you put two screws in each side. After I'm done screwing down this side, I move it over, I do the other side, and then I walk it back, and then I make sure I screw these down nice and tight. And now the next step is to just ensure that we have the same distance along the bottom of the Z-axis as the top. If there is any inaccuracy here, it could your X-axis could bind as it travels up and down. So we measure them. If they are out in any way, we'll just adjust the screws that are holding that axis in. The next step is we want to make sure that the Z-axis base is the same height at the bottom on either side. We're going to use the measuring part of this Z-axis. So we want to make sure we're starting on an even playing field. So we want to double check that the rails going into the base are the same distance above on either side. So what we'll do is we'll go on each side, we'll take a look, and we'll just make sure they're the same. On mine, they were. If one of them is higher or lower, you'll just go underneath, tighten those screws down, and that should pull one side down further. Now the next step is installing the Z-rods. I did this out of order. If you go by the book, they have you put the Z-rods in already and then assemble that top piece together. I didn't want to do that. It seemed fiddly. So I did it afterwards. The first thing I did was adjust these couplers. We want to make sure that the shaft of the Z motor that you see in the middle of the coupler is below the center line. Now this first picture has it above. That's not good. The next picture you'll see right here has the shaft below the center line. If that shaft is above the center line, the Z rod is going to sit on top of it. As the motor moves, that shaft spins. That's what brings our axis up and down. And if the Z-rod and that shaft are touching, there could be slight vibrations, which can be imparted to your prints. You might get some ghosting, you might get some ringing. After we're done with that, we tighten the bottom screw of that coupler down. That'll keep it in place so we can then put the Z-rod on top. Like I said, I did this out of order. I did the Z-rods after the top assembly was already installed on the base. I think it's easier, but it does require one extra step, and that's removing this top plastic Eryone piece. It's 3 screws, it comes right off, and this is going to let us just drop those Z-rods right in. We don't have to try and handle them and catch them as I'm trying to put this whole assembly in. I found it to be a simpler way of doing it. Here we have our Z-rods. They were pre-greased, and all I'm going to do is drop them down, and they should find their way all the way down to the coupler. Now we want these Z-rods to sit completely flush into the bottom of the coupler. And of course, because we already adjusted the bottom, the shaft is not going to touch the Z-rod, which is good. So there I go, pushing it all the way down to the bottom so it's sitting flush. I'm also making sure that these Z-rods are completely vertical and in the center of that axis or of that extrusion. And then we're tightening up the top screw. And that top screw is what holds the rod, the Z-rod or the Z-screw in place. So that while the coupler itself moves, the Z-rod moves. And that's what brings our extruder and our X-axis gantry up and down. Now the next thing I'm going to do is unscrew very slightly this threaded holder. Now this part right here that I'm doing holds the Z-rod in place, and it usually comes pretty tight from the factory. We want to loosen it up a few turns. We don't want there to be wobbly and significant play, but we want there to be a little bit of movement. So while the Z-axis is moving up and down, it can do so freely. So just a few turns on each screw should be enough to give our Z-rod just a little bit of play inside that threaded holder. And now we are basically halfway there. I just had to reinstall that top plastic piece. And now this next part I'm going to do is not in the manual. It's what I always do on printers like this where the Bowden tube goes all the way down to the nozzle. What I did was I took that blue collet off, I removed the Bowden tube, and then the silver pneumatic coupler that's on the top of the hot end, I unscrewed it one full turn. I then reinsert the Bowden tube as far as I can get it down. I put that blue collet back in, that locks it in place, and then I tightened that silver pneumatic coupler all the way back down, which is about one full turn. Now what this is going to do is it's going to pull that Bowden tube down to the nozzle even more. And then the next step after that is installing the fan shroud. And now fan shroud also, like we talked about, has our hot end in there. So we want to make sure that this fan shroud is tight to the X-axis carriage. It's only 2 screws. It's very simple to install, but if we have any vibration, any movement in this fan shroud, it's going to give movement in our nozzle and then thus movement in our prints. So we want to make sure this is tightened down very, very securely. Moving on, we install the spool holder on top of the printer. There's only 2 threaded holes where these screws can go. You really can't mess it up. The hardest part here is just getting your hands underneath there to try and screw it on. But it's a nice metal spool holder. It's made pretty well. Then after that, we're on to the electrics. Very simple. There's 3 plugs. The first one there is the X-axis plug. Now it says X right there, so I put that right on the X-axis motor. The next one is this big black plug. There's only one spot for it to go. It goes right under the extruder there. Want to make sure that's in there nice and snugly. And then after that, we have 1 plug left, and that's it for the electronics. And it's the extruder motor plug, and there's only 1 spot for it to go. You can see it exposed right there. I'm going to push it in. After I'm done doing that, I just make sure all the plugs are in there securely, and that's it for the electronics. Now here I go to look for the eccentric nuts to try and tighten them. Normally on printers like this, the Keela, the Ender 3, there are adjustable nuts on the wheels that move the axes. This machine doesn't have them. It's good because there's no calibration involved, but it's kind of bad because there's no calibration involved. You have no control over it. Moving on, I'm going to tighten the belt all the way to the right of the X-axis. There's 2 screws. I loosen them. I put an Allen wrench between the tensioner and the rail, and I pull it pretty hard. That tightens up that belt. When I get it to a nice tight fit, I start screwing it back down, and that should keep the belt nice and tight. After that, we go to the Y-axis, the front to back movement belt. This is what's going to move our bed. This tensioner is a little more obvious. Move the bed all the way back, and you'll see the 2 screws exposed. We unscrew those, we loosen them up, and then we pull that tensioner as much as we can towards the front of the printer. People always ask, how tight should belts be? You don't want them so tight like a drum where you can barely compress them if you wanted to, but you don't want them loose and saggy. When you push on those belts, you want there to be a little bit of tension, a little bit of give. It's all playing around with it. After a while, if you think they're too tight, you see black dust or black belt residue, that means they're too tight. So go ahead, back them off, and you can loosen them. The way my printer came out of the factory, they were very loose. When I pressed on the belts, there was no resistance. So I went ahead and I tightened both these belts down. After you get a good tension, you screw those screws in, and then I give it a little front to back movement to see how it feels, and it's on to the next step. Now here we're going to calibrate our x-axes. This is awesome how Eryone has set this up. There's a measuring stick on either side, so I can simply look and see this is the left side of my x-axis. This is how high it is. Now I look to the right side. I see where it's at. On my printer, it was about 1 millimeter too high on the right side. We usually only want to adjust the right side. The left side has the extruder on it. It's got a lot more weight, so we're going to always adjust towards that side. All I'm going to do to adjust this is move the couplers in the back of the printer. So I want to adjust the right side. I hold the left coupler so it doesn't move, because if I go to move any coupler, the other one's going to want to move. I hold the left coupler and I adjust the right one, counterclockwise or clockwise, in whatever direction I want this axis to go. Once it's lined up on the measuring points on the same spot, that's it. I'm done. We can move on. One of the last steps is to put the button on the front of the machine. That's what's going to let us scroll through each of our menus. Simply clicks in. Take all the plastic wrap off the glass bed. We reinstall it, and then Eryone has given us these small plastic hold downs. They screw in. They work pretty well, and they are very minimalistic, which is nice. You don't have these big binder clips that you have to worry about. These are small. Our BL Touch should have no problem navigating around these. Now, the assembly having been finished, we're going to plug in our printer and we're going to power it on. You should see an Eryone startup menu. And then after that, the first thing I like to do is auto home this machine. It shows us that all the electrical components have been set up properly and that the end stops are working. Now, in this case, there are no end stops, it's virtual end stops. So we're going to see how this printer actually goes along its axes and finds those end stops. So right here we have the x-axis and then the y-axis. Those are both going to go to their end stops, find it, and now it's going to start moving down. And what you're going to see I'm going to do is put my finger right under that probe. I do this the first time just to make sure that the engaging of that probe will stop the nozzle from moving down. If it doesn't, you could crash into the bed and you could damage your bed. So the first time at home, you want to just do that. After that, I turn the printer off, I turn it back on, and then I auto home it once more, and I want to see how it actually homes. Now you'll see my big nose sticking over here in the corner. I'm watching the entire time. I want to see how everything's moving. The axes, the wheels, and most importantly, the probe. I want to see how close it's going to get. I did notice that it's homing itself in the top left corner. Now I don't like it to home on the front left for whatever reason, probably just aesthetics. So I'm going to make a change in the firmware a little later, which you'll see, that has it home in the center of the bed. The next thing I do, as I do to all my new printers, is calibrate the E-steps. I have an in-depth video on calibrating the E-steps, and that video can apply directly to this printer. It's all the same. I highly recommend it. I'm going to link it here, so I'm not going to go into the minutia of it now. But the reason we do stuff like this is our printers are inevitably going to run into issues. We're going to have problems. We want to make sure we start it off on solid ground, on solid footing. You'll hear me say that a lot. So we make sure we do all the work up front so that when we do encounter a problem, we know that our foundation was good and we can diagnose it from there. Next, we're going to calibrate our Z-offset, and Eryone has made this really simple. It's all baked into the menus. We're going to navigate to the Calibrate Z menu. After that, we're going to be a prompt on our LCD that's going to let us lower the nozzle towards the bed. What we want to use is a Post-it note or a similarly thick piece of paper, and then we're going to move the nozzle closer to the bed by rotating the knob. This will decrease the number. And then what we'll do when we get it close enough towards that bed, we're going to put our Post-it note between the nozzle and the glass bed. We're going to continue to lower it, and we're going to keep moving that Post-it note back and forth until there's a slight amount of drag. That should give us a good distance between the nozzle and the bed for our prints to stick and get nice squish. Once we get slight drag on our piece of paper, we're going to save that Z value, and that immediately gets input into the probe Z-offset. That's all we have to do. After that, I go back to my configuration menu and I save those settings just in case we turn this machine off and turn it back on again. It'll be saved in there. Next, what I want to do, and this is completely unnecessary, you wouldn't have to do this, I wanted to see if this printer came equipped with thermal runaway protection, an extremely important software safety feature. I removed the thermistor and I heated the hot end up to 212. Now, after about 30 seconds of my hot end being heated up, there should be no temperature detected, and the printer should automatically stop, and that's exactly what it did. If this didn't trigger this error, our printer would continue to heat up indefinitely. to well beyond 212 degrees. 300, 400, who knows? Eventually it might burn itself down, burn something down. So the fact that Eryone included this out of the factory is tremendous. Really nice job. I appreciate it because not every printer, for some reason, does. After that, it's on to printing. Now, my first print's going to be a level print. I always do a level print just to see how this BL Touch is triggering and reading. And the first thing I notice is the amount of trigger points on our BL Touch. It comes equipped with 9 points and only 1 probing per point. So that's 3 points on a line and 3 lines. For a bed this size, that is nowhere near enough. And the fact that it only takes 1 probe reading per point is not near enough either. And the probe itself is moving at a pretty high rate of speed. So right off the bat, I didn't like that. The second thing I saw was the purge line. The purge line that comes with Cura's stock setup is on the front of the bed. I don't like that at all. There are bed clips up there that we could possibly hit and run into. So that's another change I noticed I wanted to make. So as I said, this is a bed level print. I usually run this to see how well I've leveled my bed. Obviously, there's no leveling need be done on this machine. So this is going to determine how well our ER Touch is operating. And now this is going to be a fast forwarded version just to show you kind of what it looks like as it goes through. I put my finger over the skirt that gets printed around it just to see how well it's sticking. And you can see it's starting to turn out pretty well, except that front right corner. It looks like it's non-existent. That's because it's printing way too close to that front right corner. And now here's the results of that bed level print. The front left, the middle, and the back left looked stupendous. However, the back right and the front right are looking like they're printing too close to the bed. You can see the corners where they're looking transparent, non-existent. The skirt's not even there anymore. That means the nozzle's too close to the bed. We have to do something about that. On a normal printer, we would go under our bed, we would adjust the bed level knobs. We can't do that with this printer. So how am I going to fix that? I'm going to go into the firmware. I'm going to give this more probing points, and I'm going to have it probe multiple times for each point. This way, the printer will have a better virtual mesh to print on, and it will be more accurate when it's printing that first layer. So here is the beginning of a brand new bed level print with the updated firmware. And already you can see the probing is being done much slower, which means much more accurately. And you're also getting 2 probing points per spot, which will mean it'll get a more accurate sense of how level this bed is. We're also getting an additional 2 probing points per line. So instead of a total of 9 points for this very big glass bed, we're getting 25 probing points. That is going to make the virtual mesh much more accurate, which means our first layer is going to print much, much better as a result. And speaking of results, here they are. They sort of speak for themselves. All these squares look phenomenal. Everything is printing as it should. And now we can start moving on to different prints. So here you're going to see a bunch of calibration prints. I start with an XYZ cube and I work my way up. All the while I'm making constant adjustments to the firmware and to my slicer settings. Now I noticed right out of the box this firmware was printing at a high rate of speed. I think on certain levels like this benchy, you can see improper print artifacts because of that, as well as some really poor overhangs. Now I don't think that was the firmware. I think that's a parts cooling issue. So I'm noting all these things and I'm making adjustments. This next print is a torture test. It is a torture toaster, as a matter of fact, and it tests a ton of different things, bridging, overhang, clearance, and it printed really, really well. I felt like all the little tunes were getting there. I wanted to try something supported and something with fine texture. And this is the mask for Green Arrow. It has both things. It needs to be supported. And look at that small, fine detail. It printed it really, really well. So I could see I was getting places. Those supports just melted off. The support stayed on the build plate and the mask pulled off. After these prints finished, I was pretty happy, but I still thought I had some bridging issues, some parts cooling issues. I printed out a new parts cooling fan shroud. I attached it. I wanted to judge it based on the old benchy to a newer benchy. And look at that. That overhang, it looked thermal, looked melted in the first, is perfect in the second. Same thing with this spout. You can barely see the center of that spout, and now it looks phenomenal. The front here, the bow isn't too bad. I hope that's the front, but still we see those overhangs. Now look at the front of this boat. It looks tremendous. I was very happy. I wanted to use the full vertical access of this printer, and I did. This is a frontman mask. It was very popular around Halloween 2021, and it is absolutely gorgeous. This is printed with Overture matte filament, which helps to hide any layer lines, of course, but this is probably one of the most beautiful prints I've ever produced. It is really, really phenomenal. Again, look at those supports. They just cracked off. This is also a fairly low supported model, but this came out stupendous. I was blown away by the quality in this mask. Here is this collection of amazing prints that have been produced by this printer here. I was blown away. I'm continue to be blown away. I've had this printer for now, since the beginning of this video, for about 3 weeks. That's how long I drag my feet on these videos. And it's continuing to put out high quality prints every time. I'm really astonished. At this point, I think I would give this the nod for the best beginner or intro 3D printer, just because how easy it is to assemble it, get it up in printing, and then produce these high quality prints. Now, of course, that wasn't without some trials, some tribulations. I made some firmware adjustments. I made some slicer adjustments. I even printed out this fan shroud that was a community member created, and that definitely helped the bridging issues, some parts cooling issues. However, because I kind of front loaded all this work, you don't have to. I'm going to link my firmware. I'm going to link my Cura profile. This way, once you get this printer, you can upload the new firmware, you can change the Cura settings, and you are good to go. You can start printing. Now, as far as updating the firmware, going to be a separate video, going to be a short video because it's very, very simple. As a matter of fact, you can learn how to do it without me. The instruction manual that we went over is about 21 pages or so that has the procedure on how to update your firmware. You would just use the firmware that I linked below, upload it to your printer, and you're good to go. So I call it a beginner-friendly, beginner-perfect printer, but some of its strengths can also be weaknesses. The lack of calibration is a strength, but then the lack of calibration is also a weakness. I can't adjust any of these wheels because there's no eccentric nuts. I can't adjust the bed because there's no bed leveling knobs. Now, if something goes wrong a little further down the road, that might cause an issue. As of right now for me, it hasn't. It's been nothing but a boon. So overall, I'm happy. If you can find this printer on sale like I did for $159 with everything, buy one, buy two, buy as many as you can because they are awesome. I mean, this is me 3 weeks departed from when I first got it. So I have put a good amount of prints on it. I would say 260 hours or so of printing on this, and I haven't had a problem. This base extruder, this base PTFE tubing, they're all still doing well. So folks, thank you so much for staying this far into the video. If you liked it, if you like what I'm doing, you want to see me make more, please like, subscribe. I know it's been such a long period of time between this video and my last. I just had so much going on. Like I said, I had the Etsy shop. It was doing awesome thanks to some of you viewers and just people in general. Really, really appreciate that, but I love making these videos. I'm going to continue making these videos. The next one's going to be a short one on the firmware update. After that, we're going to jump back over to the VoxLab Aquila. I want to do some more intro things on that, nozzle stuff, maybe octoprint, things like that. So, as always, until next time, ladies, gentlemen, everyone else, keep on printing. I feel like I'm not saying Eryone right.